This video is all about doing frequency histograms and frequency distributions using the calculator. We're going to show you a wise and efficient way to field a problem like number 36, which you can see on the screen in front of you right now. Now obviously this is a data-driven problem, so if you'd like you can pause the video and you can key this data into your own calculator so you can follow along. When I do a data-driven problem, I always want to make sure that I'm not contaminating my current work with some kind of artifact data that's hanging around from a previous problem. And as you can see in this particular case, I do have some data hanging around in list 1, which is the list I'm going to be using. So I probably would like to clear that, and you can clear that a couple of ways. For many problems you're using more than one list, and so the most efficient way to clear data is to use the clear list command from the stat menu. You just hit number 4 and then you tell the calculator the names of the lists that you want to clear, separated by a comma. Now I don't have any data in list 2, I'm just showing you the syntax of the command. So now as you can see, the list number 1 that we're going to be using here is empty. And so then you can begin to key in your data, and so on. And so again, if you'd like to pause the video and key in this data, please feel free. So as you can see, I've taken the liberty of keying in that data, and at this point I'm ready to begin the problem. Now if you read what the problem is asking, you'll notice that we're not taking it in the order in which it is asked, and the reason for that is that the calculator does not do exactly what we want it to do. So we have to sort of engineer a workaround, if you will. And so you'll notice that the first question it's asking is regarding the frequency distribution. They want us to make a frequency distribution with 6 classes, and they want us to choose the limits and the class width and so on and so forth. Now you can use the calculator definitely to help with this particular step. Let me show you how. You go back to your calculator and you can see that I've entered in the data, but it's all jumbled up. It's right out of the table, and so it makes it very difficult to see what's going on. It'd be much easier if you went back to the stat menu and you sorted the data. That way you'd be able to see the range much more clearly. So I'll use command number 2 here, sort ascending, and the list that we're sorting is list number 1. And now if you go back to the stat menu and take a look, you can see that the data has been sorted. That makes it much easier to figure out what we need in terms of a frequency distribution. So as you can see, the smallest data value is 6.37, and the largest data value is 23.59. And they are asking us in this problem here, if you can read, it says in part A, if 6 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. So we need to calculate how many or how wide our classes need to be, and we want to figure out where to start them as well. Now the calculator is showing us that again, the smallest data value is 6.37. That is not a convenient value to use as a lower class limit, because if you use a decimal value like that, it's going to mean on a practical level that all of your other classes are going to have decimal values for the lower and upper limits, and it's going to make you think a lot harder. So since we're doing this by hand and not using automated software, we want to make this as easy as possible. So here's what we're going to do. We know that the largest data value is 23.59, and we know that the smallest data value is 6.37. So we want to find the range, and we want to divide that range into 6 classes. And so this is giving me a value here of 2.87. Now I could use that as a class width, but it's a very inconvenient value to use, and so we'd like to choose something that's a little nicer. And if you understand, we can't really round it down, because if we round it down, that means we're not going to capture all the data in 6 classes. If we round it up, we have to be careful, because we don't want to have empty classes at the start or the end of the frequency distribution. It's never a problem if you have an empty class in the middle somewhere, but you don't want to have one at the start or at the end. And so in this case, I think I'm going to round this to 3. And we can actually, if we start this frequency distribution with the lower class limit of the first class at 6, a class width of 3 is going to work rather well, because if you'll notice, 6, which would be our lower class limit, and then we take 6 classes at a width of 3 units each, that gets us to 24. And so clearly that very largest piece of data, the one at 23.59, that will be captured by that last class. And so as you'll see, this is a good classification scheme, and this is the kind of thinking you want to engage in when you want to make a frequency distribution by hand, as we're doing here. So if you look at the question again, it's asking us to construct 6 classes. And so what I normally do if I'm making one of these by hand is I make the lower limits first, and then I figure out what the upper limits would have to be. So in this case, we're going to start at 6. The next class would be 3 units up from that, which would be 9, and then 12, and then 15, and then 18, and then 21. And we also want to put in the upper class limits, and once you have all the lower class limits in place, it makes it much easier to understand what those are going to be. Now this lower class is stopping just before 9. And if you look at the data, your data values have 2 decimal places, as you can see. And so that means that you also want to have 2 decimal places in your class limits so that it's clear to anyone using your classification scheme where a particular piece of data is supposed to go in the frequency distribution. So my next class is going to go, my upper limit on this class is going to go up to 8.99. My upper limit on this class will go up to 11.99. This one is going to go up to 14.99, 17.99, 20.99, and if there was one more class, it would start at 24, and so this class is going to go up to 23.99. So now we have our classes, and now we want to go back and get the frequencies. Now, like I was saying, the calculator will not do a frequency distribution automatically for you. It will do a histogram. So what we're going to do is we're going to generate the histogram and then use that to populate the frequency distribution. That's the workaround that I was referring to. So you need to go to the stat plot menu, and you need to select a plot. I'm going to use number 1 in this case. This is turned off, so I need to turn it on. And then I need to select the appropriate type of plot, which in this case is a histogram. That's what I'm looking for. And so you'll notice that the X list, which is the data list, is list 1, and that is where our data is. And so at this point we're good to go. We can just have the calculator generate that histogram for us. So you could graph it right away, and you'll see that if you do that, it's not a very satisfactory picture. So clearly the window needs to be changed in order to fit our data set. And you can do that manually, or you can have the calculator give you a kind of a good start. And so in order to have the calculator help, you can go to the zoom function, and you'll notice down here number 9 is zoom stat. And so what that does is it looks at the data set, and it gives you kind of a rough window size that's going to make everything fit in the visible window. So you just have to press 9 to select that, and now you can see that we have a histogram. Now with this particular histogram, we can't use it because if you'll notice, it has 7 classes. It has 1, 2, 3, 4, 5, 6, 7. So clearly we need to do some adjustment. And notice also we have an empty class here in the middle, which is perfectly acceptable. What we were saying before is that you can't have an empty class at the beginning or at the end of the histogram, because that indicates that you didn't think carefully when you assembled the classification scheme. So what we need to do is adjust the window size to make everything work for us. And if you look up here, you'll notice that the window starts at 6.37, which is the smallest data value, and it goes up to 26.46, which is out of necessity. So we're going to change that. We're going to start at 6, and as we said, if you have 6 classes with a width of 3 units each, that means you're going to go up to 24. And the X scale in this particular case is the class width. So we're going to change that to 3. Hopefully you would recognize where the 2.87 that was there came from. It was the range divided by 6. But in any case, as far as the Y values, it's a frequency distribution, so there's no negative Y values that will be displayed. You can only display positive ones here. So I would change that to 0. And I want to give myself a little bit of breathing room. I'm going to go up to 25 on that. The Y scale, in this particular graph, the Y scale is going to be the distance between the hash marks on the Y axis. And so it's not going to look good if you have, if the window is covering 25 units and you have a scale of 1. So I would change that. I'm going to go with 5. You can go with whatever seems good to you. And so now when you graph that, you can see that you have your histogram, and it's what we want. It has 6 classes, 1, 2, 3, 4, 5, 6. Now here's where we get our frequency distribution. You're going to use the trace function, and you'll notice that down here it's telling you the class width, and it's also telling you how many pieces of data fell into that particular class. And so if you use the arrow keys, you can motor around this graph to find out the frequencies. And so you'll notice what they are. And so now all you have to do is put them into the frequency distribution. So once again, the frequencies were as follows. The first was 15, and then 9, 4, 4, 2, and 1. So you go back to your frequency distribution, and you put in 15, 9, 4, 4, 2, and 1. And that's it. Now, the question didn't ask for the cumulative frequency, but it does come up, and I figure, why not kill two birds with one stone? So if you're trying to do a cumulative frequency, all you're doing is you're keeping a running tally of how many data values you've come across in the class, in the current class plus the classes before. So obviously, in the first class you have 15, and in the second class it would be 15 plus 9, which would be 24, and then this would be 28, and 32, and 34, and 35. Now, the relative frequency is asking for the proportion of data values in a particular class, and that has to be calculated. So in the first class, we know that we have 15 data values, and we know that there's a total of 35. So the proportion of data values in that particular class would be 15 divided by 35, which you can see comes out as a decimal number. Now, in statistics, one of the common problems that we have is that students tend to overround. And so for us, giving something to 4 places is sort of routine. And so for no particular reason other than that, I'm looking at this and I'm thinking I would probably render that to 4 places. So in other words, when I put it into my frequency distribution, I'm going to round it to the 10,000th place. And so I would round that to 0.4286. And so that's what I'm going to put in here like that. And then, of course, the rest of the cells would be filled as shown. The next one, for example, would be 9 out of 35. So again, I'll go back to my calculator, and I'll do 9 divided by 35. And so I'm going to render that as 0.2571. And so on. And of course, the cumulative relative frequency would be generated in the same fashion that we generated the cumulative raw frequency. So we'd put 4286 here. And then for the next cell, we would take the sum of those 4286 and 2571. Let's see what that is. So that comes out to be 6857. And so on. Now let's make sure we're answering everything that the question is asked here. So in part A, it's asking if 6 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. And so if you recall the values that we came up with for that, we used 6 as a lower class limit, and we used 3 as a class width. Now as far as part B is concerned, the frequency distribution that it's referring to is this column right here. So we've done that. And as far as part C is concerned, the relative frequency distribution, we started it. It's going to be this column here, but I'm not going to finish it just to keep the video at a reasonable length of time. Part D is asking for a frequency histogram, which we had on the screen of the calculator. If you recall, it was this. And for an exam question or for a question in MyLab Mastering, if you're being asked to produce something like this, most often it's going to be a multiple choice question, and you're going to get choices. So you're not going to be actually transferring this to paper, but rather you're going to be selecting something that looks like it. And regarding part E, it says construct a relative frequency histogram. Effectively, it's going to be the same picture as this. It's just going to have a different vertical scale. So you're going to have to figure out what an appropriate scale would be, but it's not that difficult to do. And then finally, for part F, it's asking us to describe the shape of the distribution. Now that's a reference to something that comes earlier in the book. Let me show you the image here. what they are asking is that you would look at these 4 images right here, which is on an earlier page in the text, and you would identify which of these most closely resembles the graph that we were looking at on the calculator screen. So again, the graph that we were looking at is here, and the choices that we have would be from here. And so if you'll notice, I would describe the graph that we saw as being skewed right, because the tail of the graph runs off to the right, just as it does on the calculator screen. I hope that's helpful. If you have any questions or feedback, I'll have my email address at the end. Please feel free to drop me a line.